Excuse me, as you remember, we have a review over the ATM case study, and we received to polymorphism and inheritance concepts, and then we left the concepts, these concepts to this session. Before we start to continuing to discuss about the ATM case study, the remain section of ATM case study, I want to show you a video about four pillars of object-oriented programming. So let me to show this video. Excuse me, let me to turn on VPN and then okay. Let me stop sharing. Oh, excuse me. Let me. Okay. Uh, I want to show you a video about four pillars of object-oriented programming, which is presented by Mosh Hamedani. Uh, this is a good video. This is a short video about the principles of object-oriented, and it's very important for us because in next part of your course we will focus on these principles in more details, and in this session we need some of these concepts to explain the ATM case study. So let me share again my screen and show a video material. Can you see my screen? My screen is titled with four pillars of object-oriented programming. Can you see? Okay, no problem. Let me play this video, and please note to this video with details, and if needed, if you will have some questions about this short video, you can ask your questions and I'll reply your questions. So let me to start this video. This is a short video about 7 minutes. Excuse me, can you hear the sound of the video? Let me to raise the volume of my speakers so that you can hear more easily. Let me see your messages. No. Let me to raise. Okay.
And functions that operate on the data. This popular interview question concerns the four core concepts in an object-oriented program. These concepts are encapsulation, abstraction, inheritance, and polymorphism.
I think now is okay. Now it's okay. I think the sound of the video. Okay or no? No? Uh, I raised the volume of my speakers. Okay.
Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you learn as part of your first programming subject at a university. But as your programs grow, you end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. Make a change to one function, and then several other functions break. That's what we call spaghetti code. There is so much interdependency with all these functions, it becomes problematic. Object-oriented programming. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the function as methods. Here's an example. Think of a car. It's an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like set item and remove item. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime.
Let me have a feedback from you about the video. Can you got in this video? Uh, can you notice the concepts? Please answer me. Can you hear me? In this video, as you noticed, Mr. Hamedani talks about four pillars of object-oriented or principles of object-oriented programming. There are four pillars, as you heard from the video. These are the four pillars of object-oriented programming definition. The second one is abstraction. The third one is inheritance. And the last one is polymorphism. We need these four principles in our lectures. Okay. As you saw before, in object-oriented programming, we use encapsulation to hide the details of our coding, our methods, or features of our objects. If you remember, in programming languages, in object-oriented programming languages like C++ or C# or Java programming language, if you have experience in working with these languages, you know that we use object-oriented principles to hide the details of implementations, the details of our methods and features of our objects in classes, and other classes or other components just see the interface of an object and communicate through the methods which is specified by the interface of each class. So we use encapsulation to hide the details of implementations and make programming more easier, make programming more pleasurable. Okay. The second principle, or the second pillar, is an abstraction. What's the abstraction? In the abstraction, probably you know, we try to hide the unneeded entity for each object. For example, in a learning educational system, we need some features about the students, about our students, such as student number, first name, last major, the college, the department name, average, courses, and so on. Okay, but in other systems, such as a hospital system, we don't need some of these features. For example, we don't need features such as department name, such as the courses, such as the grade of the degree of the person at all. Okay, so in our point of view, which is related to the project, to our project, we try to hide or omit some unneeded details about an object, and on the other hand, we try to register or save data about other features which are needed in our project. For example, some features of ours are needed in education system, but in a travel agency system, for example, some other features of ours are needed. And the features that are used in educational system is not needed in a travel agency system, for example. So the project determine our point of view, and by our point of view, we try to list some needed features and some needed methods for that project, and we forget, we neglect other features of that entity or of that object, for example, of the student in our educational system, so that we make it easier to save data for needed features, and we make some smaller set of methods for each object. By the abstraction, so by the abstraction principle, we delete some unneeded features and unneeded methods, unneeded behaviors from objects which are used in our project. And on the other hand, we save the needed features and needed behaviors as methods of our objects. The third pillar is is inheritance. As Mr. Mosh Hamedani said in this video, will say in this video, in procedural programming, in traditional procedural programming, we have to copy and paste some pieces of code ever and ever and ever. So the redundancy we will have the redundancy of our code. The redundancy of code is very bad in our projects, because when we want to update a piece of code, we should take care to update all copies that we made during our developing phase. And it is a very time consuming and very error prone activity. So copying and pasting codes in projects is not advised in software engineering, and this should be handled by some mechanisms such as inheritance in object-oriented programming. Okay. The last feature is polymorphism. We will discuss about polymorphism when you saw this video, and we use polymorphism and inheritance in this session for our ATM case study. So please note to the video again, and please ask your question if you have. Mr. Dalal, please. Assalamu alaikum, Mr. Ali. Welcome to the class. Please go ahead with the video.
Divided the program into a set of functions. So
in this section, he tells about what we should to do if we don't want to use object-oriented programming, or before the object-oriented programming in traditional procedural programming, we have some problems. Please note to this talking about the problems that we have with traditional procedural programming. In traditional programming, as Mr. Mosh said, we have some functions and a bunch of variables in each program, which they are decoupled. They are entirely decoupled to each other, and we may have to copy some pieces of code in some functions, and our functions may have so many parameters. This is not good in programming. And if you note to this video, as Mr. Mosh said, we should handle these problems by object-oriented programming.
Store a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you learn as part of your first programming subject at university. But as your programs grow, you'll end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function, and then several other functions break. That's what we call spaghetti code.
Okay, this is called a spaghetti code because functions are related to each other more and more, and we have so many complexity in our project in handling our functions because our functions uses other functions, so many, and this will confuse my developers. So this is not a good style for programming. Okay, this is called spaghetti code because the relationship between uh, our functions are so many, and our functions are dependent to so many other functions.
And then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, you don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like set item and remove item. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation.
As you noticed probably, instead of we have so many functions decoupled with each other and dependent and use other functions, and instead we have an spaghetti code in object oriented to handle this problem. We make functions as a group with some properties, some variables, and each group of function and variables make an object which is a meaningful entity in our project. For example, in our education system, we make an objects of student, and objects of professors, and objects of staffs, courses, departments, colleges, and majors, and so on. Okay, each object encapsulate a number of functions with a number of attributes related. Okay, and we named, as you know before, the attributes as property and functions as method in object oriented. So the object oriented is a solution to the problem of the spaghetti code in our traditional procedural coding. Okay.
Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. In these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled. Now let's take a look at the object-oriented way to solve this problem. You can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our get wage function has 3 parameters. In this presentation, we don't have any parameters. It's because all these parameters are actually modeled as properties of this function. All these properties and the get wage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction.
Excuse me. Who noticed this example? Who are noticed this example? Is it needed to explain more about this example? Please answer me. If it is needed, we talk about this example more. Can you hear me? Please answer me. Okay. Who noticed this example, this coding example? Explain more. Miss Mariam, can you talk about this example? What he said about this example? How encapsulation help us in programming? Who can talk about this concept? The difference between procedural and no parameters. Let me explain more about this coding example. As you saw, this piece of code, this first piece of code, is a piece of program in a procedural way, which is written in a procedural way. In a procedural way, in each program, we have a lot of which are decoupled with our functions and each other variables. Okay. When, for example, in this case study, this is a case study, this is a personal system in some organization which want to calculate the wage of its staffs. For calculating the wage of each staff, we need some parameters such as base salary, overtime, and rate for each person, for each staff. And when we want to calculate the wage of each staff, we should write a function such as get wage in procedural programming. For this function, we have to define 3 parameters as you see here. and calculate the wage of each staff by this formula. Okay, but in object-oriented slide in style, we define this piece of code as an object in which these three features or attributes are features about our employee. This is a meaningful piece of code which specify an object or a class of entities. These three attributes are attributes of each employee, and for calculating the wage of each employee, we will write a function with no parameters, because the parameters that is needed to calculate the wage of each person is encapsulated in this object, and we can simply reference in our functions. So there is no need to introduce some parameters for this function. We can simply access to these features as you see here. For calculating the wage employee, it's enough to calculate this formula. Okay. This piece of code, this function attribute coupled to each other enough to make a coherence object. Okay, but in this piece of code, there is no coupling relationship between this function and these variables. Okay, so the encapsulation principle in object-oriented help us to make a coherent objects in which the behaviors and features of each object are coupled together enough to make a coherent. Okay, go ahead, please.
As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction.
This is in an encapsulation, as you noticed, because we encapsulate the related features and related methods together in a box, and we make a name for that box, such as employee, such as a student, such as professor. Okay, this help us to avoid from having an spaghetti code. Okay.
The DVD player as an object. This DVD player has
in a piece of the video, he talks about abstraction. What's an abstraction? Who know what is who can define an abstraction in object oriented or in other industries such as electrical engineering and mechanical engineering? Who can define an abstraction? No one. Please note.
like something where you need insight. And if few buttons on the outside that you interact with a DVD player as an object. So that's encapsulation. Now let's look at the DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside.
As you noticed, as he talked in this video, we have some complex electrical circuits, some digital boards, and other devices, other hard video player. But you don't have to work with those circuits, boards, or devices of this video. You just saw a simple interface from this video with a few buttons on its panel. Okay, so you can communicate with this video by these buttons or by a remote control. These buttons define an interface of this video player, and you can communicate by this interfaces with the internal devices, internal hardwares of this video player. Okay, the abstraction more details inside the box of this video. Okay, we should learn from as hardware engineering, hardware industrial, to hide the details of our codes and introduce and specify the object by simple interfaces, such as done in electrical or mechanical industry. Okay, go ahead, please.
This is abstraction in practice.
The complexity video player is hidden inside the box. This is an abstraction. We want to hide the complexity inside a class and introduce some interfaces, some public methods as an interface of the class. And other classes can communicate with the considered class with its interfaces, with its public methods, the methods of the class under consideration. Okay.
We can use the same technique in our objects. So we can have some of the properties.
Please note, in this class, in object-oriented programming, we can hide function and all of the inside the class. Okay, and just externally needed functionalities. Some externally needed the interface of this class. So classes can come with this class by these two functions, two highlighted. Other functions and attributes can by as you know in previous lectures, by visibility, such as private and public. So in implementation, should the three functions as well as these three attributes. But these two functions should be defined as public to be accessed externally by other classes. Okay, so go ahead, please.
A couple of benefits. First is that it will make the interface of those objects visible.
The first benefit of this pillar or this abstraction concept is that we have simpler interface. Our developers should know more details about internal structures. Okay, simpler interface to avoid confusing our developers which want to use our developed class. Okay.
Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us to reduce the impact of change. Let's imagine that tomorrow we change this inner or private methods. None of these changes would leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, reduce the impact of change. Now, the third core concept in object-oriented.
Excuse me. Have you noticed this second benefit of the abstraction? Please answer me. If no, I want to talk more about the second bit of abstraction. What's the meaning of use the impact of change? How can reduce the impact? Are you in our class? Feedback from you. Feedback from you. No problem. I talk more about this concept. Please note how abstraction principle causes to reduce the impact of change. The question is how the abstraction can reduce the impact of change in each class. Please suppose this video player could be produced by several producers. Each producer can have its own internal design for video player. Okay, each producer of video players can have its own design of video player, but the external view of this external interface of the video players okay or almost are the same, and each producer can change its internal of video player okay, and there is no problem in changing its internal, but if a producer want to change some interfaces such as these ports, it make a problem because probably this video could be special and has not a standard port to use by our users, because our users have some television set or other sets which have a standard base and we cannot communicate with the new special ports. So no producer can change the interface freely, but each producer can change its internal design freely. Okay. Other hand, when we want to repair some hardware such as this DVD player, we can permit the fixes to change its internally devices freely. Okay, with no problem. So the changing in internally hardware, in internally circuits of this video player will have no side effect for end users, because the end user just use these ports and these buttons which is located on this panel, and they have a standard, they have standard behaviors. Okay. In object-oriented programming, when we use an abstraction principle, we hide some functions and features, and we hide the details visible ever. Okay, so the developer of each class can the hidden attributes with no side effect for other classes in our project, because other classes just uses these function interfaces, and the developer, the owner of this object, the owner of this class, also can change the implementation of these two object ever the internal implementation of this also. Okay, so the abstraction can reduce the impact change. The impact of change of change are limited in this box, and they can prop to the external classes. They can not affect the external classes. Our external classes in our project Excuse me, my connection. Hear me now? Okay, okay. I'm sorry. Let me share again. Okay. As I told you, and as I told you, the abstraction can reduce the impact of change by when we changing these internal functions and internal attributes. Other class note from this changing because other classes can communicate with this class just through these two public functions. So the chains are limited to this class and has no effect or other classes. So the second benefit of abstraction is reducing the impact of change. And the abstraction doesn't permit the class change through other classes. Okay, go ahead, please. Third, uh, pillar of object oriented, which is inheritance.
Responses, drop down list, function, and so on. All these elements have a few things in common. We should have properties like hidden and index. Redefining all properties and method HTML can define them once in a generic object, calling HTML elements, and have other objects in these properties and methods. So inheritance helps us eliminate redundant code. And finally, poly means many, more means one. Polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. Rendered is different from the others. If you want to render multiple HTML elements in a procedural way, our code is like that. But with object orientation, you can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object you're referencing. So we can get rid of this natural kind of code like you will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of the program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor only switch case statements. It's me, Mosh, again. I wanted to say,
Okay. As you note, in this slide, we see concept. These four concepts of object programming have its own benefits. As I told you, the encapsulation principle can reduce the and increase reusability of objects or our classes in our project. The abstraction principle reduce complexity and impact of change, inheritance, and polymorphism, as we will discuss in our ATM case study. Next, the inheritance redundant code and avoiding us to make copying and pasting into several can make our code more elegant with eliminating if then else and switch cases from our programs. We will see the benefits of these two pillars or two our ATM case studies soon. So let me to switch on the case study. I'll send you the link of this video. Yes, this is your WhatsApp group and this is the link of video. Please take a look at this video and in our study. As you saw, as you remember in previous lecture, I talked about the implementation of the simple design of our ATM case study. Before we continue on this ATM case study, let me to see your messages and reply your questions. Let's Ms. Hala Hassan said that the concept of that shows essential attributes and hides unnecessary information. That's right. Thank you. Representation of key features without including background details. Yes, it's okay. Font cutting. No problem. No. To reduce the complexity and allow system to be designed efficiently. All of your comments are right. Thank you for contributing in our class and for your okay. Let me return back to the ATM case study. As you saw in previous lectures, we reached to this design model, this class diagram, which are discussed, which is discussed in previous lectures. As you know, we have a ATM class, keypad, deposit, bank database, and account. And we talked about how we will implement this class diagram in practice. As I said before, we start with classes which has no dependency to other classes. So we in implementation phase, we start with these classes which they have no dependency to other classes, as well as the account class. When these 5 classes are implemented, we can continue to implement the classes which have pendants. For example, we implement account class, then we can make a bank database class, because the bank class then account, and when we have an account class, we can simply make a database class. And we can continue to making augmenting other classes. In this case, then we implement a withdrawal class, and after that we implementation. In this lecture, we want to introduce some other principles that are not used till now, to use in inheritance and polymorphism in these cases. We talked about this procedure to implement, and we have saw some implementations code for this simple design of ATM class. In the next topic, we try to incorporate into this ATM case study. As you know, these classes with some piece of code in common. For example, all of these three classes have a method, have an execute method, and all of these three classes have account number attribute. So in order to eliminating this common code from these classes, we can use an inheritance possibility of object oriented programming in order to reduce these codes. Okay. So please see how we can use inheritance. As this figure, we eliminated the common codes in these three classes. As you saw, the account number is a common attribute for all of these three classes, and methods are used for all of these three classes. But you see here that we have a redundant now, because we use exec in each of these subclasses in this design. Why we should make this redundancy in this design? We make a subclass, a superclass named transaction, and all of these subclasses can inherit features and methods of this transaction class. So the balance inquiry can have access to its own account number version by inherit mechanisms of programming, and its own access to get account number or execute method of this transaction. But in this design, we have a redundancy in for method execute. We copied this method again to these subclasses. Why we make this decision? What of this design? This is because the of balance inquiry is entirely different with execution of withdrawal. Withdrawal transaction, we should reduce the balance of each account by the amount value. Balance inquiry, we just read the amount value of account to the, so the execution of balance inquiry is different from execution on execution of execute method of withdrawal object or withdrawal class, and so on for deposit. The execute method of this class is different from withdrawal and executing of balance inquiry. So we have a common method named execute in a superclass, but each of these classes should have its own implementation for the execute its execute method. Okay, because the execute method for balance inquiry is different from withdrawal. This is polymorphism. This is polymorphism. Means many forms. We need 3 forms of execute method. We need, in this design, we need 3 forms of execute method. This one, and this one. Okay, this is a polymorphism example. The polymorphism is meaningful when we use inheritance. Another question is that happen when we want to eliminate this execute method from transaction. As you know, subclasses on execute method. So why we use this execute method in this? Can you answer this question? Let's make it's inheritance method. Just for inheritance? No. It's answer to this question. Miss Fadia said transaction contains the object. The execute is a method, not an object. Please note that the execute is a method. Each transaction should be executed. We have no instance of this transaction class in our project at all. We make instances we make instances of, for example, balance inquiry, withdrawals, and practice. Okay. So my question is that why we find this execute method in transaction when we know that our subclasses should have its own execute method. Why we use this execution in transaction? very important to know. For example, suppose that we have a banking system which receives requests from several terminals, from several ATM machines. So the banking system should make a queue of requests. And you know, requests are not identical. Some of them are transactions of type, some of them are withdrawal transactions, some others are deposit transactions. And the our banking system should make a queue of this all in list. As you know, in languages such as Java, such as C++, such as C Sharp, we have a static type checking, which means you cannot define an array of multiple types of data. You can define an array of integer, an array of string, an array of Boolean, but you cannot define an array in which its elements could be in several types. Some of its elements be integer, some of them be double, some of them be a string, and so on. The types of the elements in an array should be identical. All elements should be, for example, integer or string or double, but not combinations of them. Okay. So when we have to make a queue of requests, a queue of transactions, we should of transactions. The type of our object should be injected in our list or in our queue. For this reason, we use the transaction type transaction, and for each element in for each transaction in our queue, call a queue. We use a for loop to execute method of each element queue. Okay, so we need to define the execute method in our superclass in order to make a possible when we use a list of transaction, each transaction in its own type, we can its execute method. Okay. So this we static execute method in our superclass with no but we define special image of our subclasses. Each of these subclasses have its orientation for the execute method. Okay? So when we call this execute method is run, not this one implementation at all polymorphism. And when we define this relationship, this class inherits all features and methods of this superclass. And this is so on for other sub. We call these classes or subclass is superclass. When we read the relationship from bottom to up, we make and when we take a look from top down super subclass, we make a specialization. The binary balance inquiry is a special transaction, as withdrawal transaction is a special transaction. The deposit transaction. The transaction is our general class. So we take a look from bottom to up, we have a generalization, and on the other hand, from to our subclass, we make specializations. Okay. I hope it's clear for you. This slides to polymorphism and inheritance. I talked enough about these concepts. We have a new design separating the inheritance and polymorphism in these classes. So in the new design, we have a transaction class with 3 subclasses: withdrawal, deposit, and next we have the new are showed in this figure. As you see, the deposit withdrawal and balance inquiry inherits fraction transaction, and the account number these classes. Okay. And the transaction for the special versions of execute for each of subclasses. We repeat this method in our and we override implementation. Right, menu implementation for subclass, we use an override annotation, as you will see in our new implementation. In our new implementation of withdrawal class, we use extends term in order to make inheritance transaction. This is a change in to and we extend that the class transaction we eliminate account number attribute from the list of our attributes and can execute in vitro class. We use the annotation override differences of this new implement. So now you should do practice and practice for next session. You implement this design, this design. Please make actual. I want you make for as between two accounts. Make some fishes. Okay. Please make new implementation for this case study. You can see the implementation of other classes in these slides and use those implementation and make a new change. I want that you make an experience to changing this project. You will notice that this design is very modifiable. When you implement this design and after that you want to change this, you want to extend the services of this system from 3 types of transaction to 5 types of transaction, you will notice that no change through this extension. We just need to add 2 classes, 2 subclasses for our transaction. And we need to make a change in our main menu when a user, a customer enters to this system. Instead of seeing just 3 types of transaction, he should or she should see 5 types. One of the new transactions should be, for example, transfer of money between 2 accounts, or do some payment for other organizations. Okay, so please make a new implementation for this case study for next session so that you make a good practice. You have seeing of the impact of our design on modifiability. You know, modifiability of our systems, our software product is one of the quality attributes, one of the important quality attribute. Okay, and by this practice you will learn how to make a good design so that rise the modifiability of the system. Thank you for your attention. I think it's enough for tonight. Please ask your questions if you have. Let me to stop sharing and stop recording. The best for me is to do this practice for next session, because the next session I will switch to the next part of your course. The first part of your course is we simply review some concepts from your bachelor grade, from your bachelor courses, and in the next part we just talk about some other principles of object oriented, take a review of other concepts of object oriented programming in more detail, and in the third part we should take a look, a deep look on design patterns. The third part of your course is design patterns. So we should start soon the third part. We have no time for the second part, because we have talked enough about the principles of object oriented in this case study. We just dedicate about 2 or 3 sessions for the second part. So in the second part you should experience these principles in practice. So the best is to do for next session, but if not, for next week. Miss Fadia, I don't notice your question. Where transactions are kept away from the screen, the transaction needed the screen to show its messages. Because customers want to see any feedback from system when they make a transaction, when they execute any transaction. They want to see the result of the execution. So the transaction object should use a screen object. Not all transaction. No, all transaction want to use. Why not? Why not? Thank you again. See you next session. Have a nice night. Bye for now. Thank you very much. Good.